Okay, so this will be the last video for the online class for Friday, the Friday before spring break. And so what we're gonna do today with this online class is do some derivatives, but then these last two problems are like what we worked in class today and just practicing the implicit differentiation. And we have two different problems here. And we're going to take the derivative, we're going to take a d dx across these. And when we do that, the derivative of x squared is 2x minus the derivative of y is y prime. And that's equal to 4e to the y, because the derivative of e to the y is e to the y, times the derivative of the inside. Well, the derivative of y is y prime. So the derivative of the whole is e to the y is e to the y, times the derivative of the inside is y prime. Remember that if it's e to the x, the derivative of e to the x is e to the x. And if you did the chain rule on it, the derivative of the inside, the derivative of x is just 1. So there's nothing to do there. But in this case, the derivative of the inside is not x, it's y prime, or dy dx. So now we need to get all the y primes on one side. I'm going to move them over there. This gives us 2x equals 4e to the y prime, plus y prime. Then we're going to factor 4e to the y plus 1, all times y prime, is equal to 2x. Now we're going to divide both sides. So that gives us 2x divided by 4e to the y plus 1 is equal to y prime. Now what we're asked in the problem is, what is the slope of this, it's not really a function, equation is the right word. And the question is, on this equation here, what is the slope at 2, 0? And so what we're going to do is plug in 2, 0 there. So 2 times 2 divided by 4e to the 0 plus 1. And that works out to be, 2 times 2 is 4, divided by e to the 0 is 1, 4, that's 5. So we get 4/5. 4/5 is the slope at 2, 0. So working back through this, the derivative, the dy dx of the whole thing, or the d dx of the whole thing, this is 2x minus d dx of y is y prime, equals 4e to the y, the derivative of e to the y is e to the y, times the derivative of the inside, the derivative of y is y prime. And then again, we'll move the y prime over here. We'll factor out a y prime, leaving us 4e to the y plus 1. And then divide both sides by that, leaving us with this. So here's our formula for y prime. That's our formula for y prime. And if we plug this in, if we plug all those values at 2, 0 in, we wind up with 4/5. All right, so that's that first question. Now this one looks a little more difficult. And we'll see. Hopefully I have enough space here. We'll give it a try. All right, so again, we're going to do the d dx of the whole thing. So we have we have to use the chain rule here. So 3 times x minus 2y squared. But now we have to take the derivative of the inside. This is an interesting inside derivative. The derivative of x is 1. The derivative of minus 2y is minus 2y prime. So that's the derivative of the whole, 3 in front of the whole thing to the second, times the derivative of the inside, 1 minus 2y prime. And this is equal to derivative of the whole, that's 2 times 2 is 4y to the first, times the derivative of the inside, which is y prime. And then minus 3, derivative of minus 3. Hopefully you all know by now, derivative of a constant is just 0, and we can move on. All right, now this is a complicated problem. So what I want to do is, I'm going to take these y primes together. I'm going to distribute this. And so we're going to multiply this, so 1 times all of that. So I'm going to distribute this. So this is 3x minus 2y squared minus 3 times x minus 2y squared times minus 2y prime is equal to 4y prime, 4y prime. You can see we can minus a minus and 2 times 3. So this is 3 times x minus 2y squared plus minus 3 times minus 2, 6 y prime times x minus 2y all squared equal to 4y prime. I can now move this y prime over here. So this gives me 3 times x minus 2y squared equals 4y prime minus 6y prime times x minus 2y quantity squared. So now we can factor the y prime out, leaving me with 4y minus 6 times x minus 2y squared, all of this times y prime. You can divide both sides by this. So we're going to wind up with 3x minus 2y divided by 4y minus 6 times x minus 2y all squared. Now, we got to put 1, 1 in there. We want to know what this value is at 1, 1. So at 1, 1, we're going to put in, so 1 minus 2 is minus 1, that's minus 3. So it's 1 minus 2 is a minus 1, times 3 is minus 3. And then we have 4 times 1, that's 4. So 4. We have 1 minus 2 is a minus 1 squared. It's a positive 1 minus 6, so that's minus 6. So this looks like to me we get minus 3 over minus 2, which is all equal to 3 halves. So that gives us the slope at 1, 1. So on these implicit differentiation, there's a lot of ways in which we can make mistakes. So we have to be careful, and hopefully I didn't make one here. I'm working these live. I didn't check them. I probably should have checked the book for an answer or whatever, but I think this is right. So we're going to take the derivative of the whole, 3 times x minus 2y squared, times the derivative of the inside, 1 minus 2y prime, equals to 4y times the derivative of the inside, which is y prime. And then it's really just algebra after that. The rest of this is just algebra. And we get it simplified to where this is y prime. And we're going to solve this at the point that we were looking for. We're going to solve this for this slope up here. And we put 1, 1 in here. So 1 minus 2 is minus 1 times 3 minus 3. 4 times 1 is 4. 1 minus 2 is minus 1, but squared, it's a positive 1, minus 6, so 4 minus 6, minus 2. So we get a minus 3 over minus 2, which is 3 over 2. And so that's how implicit differentiation is ultimately done in a problem like that. Well, I hope you guys have a great spring break, headed a mission trip. God bless. Headed for an I-term. Blessings again. Going home to see family, all those kinds of things. Bless you guys. We'll see you on Monday after spring break. We'll have a practice test. And then on Wednesday after spring break, we'll have our third test of the semester. God bless you guys.